Good afternoon, live from UCL News. A group of fascinating young engineers have done a project on everyday essentials of chemical processes. On to Jack, reporting from UCL Roberts Building.
A piping and instrumentation diagram, or PNID for short, is a diagram used to show a chemical process and all of its components, such as pipes, pumps, compressors, and valves. PNIDs are used by companies well known all over the world, such as Shell, ExxonMobil, and BP. The purpose of a PNID is to design a new chemical plant or maintain or optimize a currently existing one. It also forms a major part of any risk assessment, ensuring that hazards are reduced and costly risks are eliminated as much as possible to protect the company and its workforce. On the screen at the moment is a PNID. It shows two components which are well known. One is a type of valve called a ball valve, shown here, and another is a type of pump called a piston pump, shown here. Let's grab our PPE, head into the lab, and we can find out a little bit more about these really important components. A valve is a device that can alter the flow of fluids in a process, and the exact use depends on the type and geometry. In assembling the ball valve, we begin with the housing. Firstly, insert the spindle and align such that the ball locks in place, and close using the ball seal. Then finally, we close the spindle up with the hand protection at the top. The ball may be rotated through 90 degrees, such that the opening is either parallel to or perpendicular to the flow of the fluid, thus allowing the fluid to either flow through it or not. It is an on-off type valve, meaning it is either fully open or completely closed. It's also a return valve, which means it allows fluid flow in two directions. The ball valve is versatile, meaning it can be used for high pressures and temperatures, as well as allowing the flow of liquids, gases, and slurries. Due to this, it is widely used in a range of industries, such as oil and gas and pharmaceuticals. The purpose of the piston pump is to move fluids. A piston pump may be single-acting, where fluid only flows out of one end, or double-acting, where fluid flows from both ends.
For the pump housing, the main assembly components are the intake and pressure valves, straight flange, air chamber stud bolt and seal, and the membrane safety valve. For the gearbox, the main components are the piston rod, packing gland, crankshaft, bearing and gearbox covers, and the duo piston. We finish by connecting the gearbox assembly with the pump housing.
It operates on a pressure difference created by the piston pump with two types of motion. Firstly, suction stroke, where the piston moves in a way which results in a larger pump cavity volume and lower pressure. As a result, there is a lower pressure on the suction valve, which allows liquid to flow in, and a higher pressure on the discharge valve that causes it to close. In contrast is the discharge stroke, where the piston moves to have a lower pump cavity volume and higher pressure. This results in the suction valve closing off and the discharge valve opening to allow liquid to flow out. Piston pumps are used in many industries, including chemical production and oil and gas. So, we've learnt about the ball valve and the piston pump and how these are assembled. We also have a better understanding of a PNID, and we know why pumps, compressors and valves really are the hidden heroes of everyday life.